Hey everyone, I'm Kenny Bastani. If you're here, it's because you're here to hear me talk about MySQL and Redis and Cloud Foundry. A little bit about myself. I am a Spring developer advocate at Pivotal. I'm writing a book called Cloud Native Java. I'm writing that with Spring developer advocate Josh Long. This is a book about building JVM applications as microservices using Spring Boot, Cloud Foundry, and Spring Cloud. So I am on the Spring team at Pivotal, and this last month I've traveled all the way around the world. Actually, it's really funny. I was in Korea talking at Kakao just 2 weeks ago, and then we have a speaker from Kakao who was in that talk here today, and he just gave that last session. So I found that pretty cool. If you're interested in any of this content, it's all in this Cloud Native Java book. It's from O'Reilly. It's early preview, early release, so I recommend going online and taking a look at it if you're interested. So what are we talking about today? So we're going to talk about Spring Data Redis. So this is going to be heavily focused on Spring, building applications with Spring. Who's heard of Spring? Anyone? Awesome, great. Who's heard of Spring Boot? Who's using it today? OK, this should be a boring talk then. OK, so we're also going to be building a Spring Boot web service with MySQL storage. We're going to do that live. I'm going to do a lot of live coding. We're going to add in Redis caching with the Spring Data Redis project. And then we're going to deploy to the cloud. We're going to go deploy it to Pivotal Web Services, which is a hosted instance of Cloud Foundry. And then I'm going to stream metrics to compare caching and no caching. So we're going to compare caching with Redis on top of MySQL and then without it. So we'll see the difference in real time. But the first thing we're going to do is I'm going to tell a database joke, because I rarely get that opportunity. So why did the database have problems ingesting data? Anyone? Come on, think about it. It's a good one, I promise. Ready? OK. Because it had acid indigestion. Yes, we're off to a good start. OK, so let's get serious. Let's talk about some architecture. So I guess no talk is complete these days without a reference to microservices, maybe polyglot persistence if you're into that kind of thing. So what does this look like? So here I have an architecture diagram of multiple applications composed as a microservice architecture. These are Spring Boot applications. So we've composed these services around business capabilities. And this example application is a movie IMDb sample application. So I'm just going to go over this diagram. And I don't really have a pointer, so I'm going to point. So we have the user service up at the top. And you see that's connected to a MySQL relational database. And then to the left, we have a movie service, which is our stage left over here, which is another relational database with MySQL. And then we have a recommendation service at the bottom, and that's using MongoDB. To the right, we have a rating service, which is using Neo4j, which is a graph database. And so the idea here with a microservice architecture is that you get to choose the technology as a development team working on a service that's best suited to solve the problem at hand. So that's very powerful. Now, with a microservice architecture, you might run into a problem with consistency, right? So you're splitting up a data model across multiple applications. And when that happens, that means that your transactions are now spanning across multiple services. You're storing state in databases across your architecture. So one of the things you can do is to share a resource or a central resource. And here I have the example of having a Redis database as a shared cache between services. Now, each service could have its own cache, but you can also use this cache to cache transactional data or events that are happening across these services that mutate state of your application. And you can use that to roll back state, which can be very helpful. You can also use something like Apache Kafka, but Redis is just a good example here. You can also use it for just a regular caching use case. So what I'm going to be talking about today is I'm actually going to be building one of these applications. I'm going to build the user service. And you see that has the MySQL database connection. So we're going to build a basic user service with a user model. And then we're going to connect it to Redis to add in caching using Spring Data Redis. So with Spring Data Redis, basically what you get is easy access to Redis from your Spring applications. It provides a variety of abstractions for you to use to connect to Redis. We just added Spring Data repositories, which is great. Previously, the old thing we have is Redis template, which most people use today. And it also has a cache manager implementation. So you can use annotation-driven caching on your methods. Also, it's available today from start.spring.io as a starter project. So I'm going to show you how to do that in a second. And yeah. So how does Spring Data work? So basically, we have a series of abstractions in the Spring Data project. And with repositories, this is what we get. We get a cascade of interfaces. Up at the top, we have our basic repository interface. that has no methods in its contract. But anything that builds on top of that is going to implement a set of methods. We provide these 3 basic repositories. So we have our CRUD repository, which is a basic create, read, update, delete repository with a series of methods that vendors will build on top of. So we have a variety of projects under the Spring Data ecosystem, including Redis, MongoDB. We have Spring Data JPA for your relational databases. And so as it goes down, it'll add more functionality. We have a paging and sorting repository with a set of methods that vendors will implement on top of. So what we're going to build is this basic cloud-native application, and we're going to deploy it to Cloud Foundry. So we're going to see it run live, and then we're going to stream metrics. So this is the basic diagram here. In the center, we have our user service. This is going to be a Spring Boot application. We're going to add in Spring Data Redis. We're going to add Spring Data JPA. We're going to just build a basic REST API. So you can see at the top, very simple diagram. We have our MySQL database. That's our relational database. And then at the bottom, we have Redis. To the left, actually, these blue ones, those are, well, the user web's going to be built on top of that. That's going to be the user interface. That's going to be built on top of this back-end service that's exposing a REST API. And at the top, I've added, just in this diagram, I actually stole this out of my book. I cheated. I'm not going to build that discovery service today. But if you're interested in Spring Cloud, that's going to connect applications together. So you can have a cloud-native application. If you deploy to an environment, it's going to check into the discovery service, provide its information of where it can be contacted on the network so that it can discover other applications that are running. But we're just going to build this main component here in the middle. So what is Spring Boot? So Spring Boot is a JVM micro-framework for building microservices, and that's a mouthful. So what really is Spring Boot? There's this excellent tweet from Phil Webb. He's the co-lead of the Spring Boot project, and he broke it down very simply, the difference between classic Spring Framework and Spring Boot. So raise your hand if you've used classic Spring Framework. Now keep your hands up if you're an expert XML developer. Anyone? Yes. Well, you kind of have to with classic Spring Framework. The idea behind this is that these ingredients here in the Spring Framework, these ingredients represent projects in the ecosystem. So your eggs might be Spring Data Redis, right? Your flour might be Spring Data MySQL or Spring Data JPA. Your butter might be Spring Security. So the idea here is that with Spring Boot, what we've done is we have allowed you a way to automatically configure these recipes, these ingredients that you have, and bake them into a finished cake with a topping and the icing on top. So you get to customize it out. You get a finished application that's ready for production. And so I'm going to go ahead and demonstrate this now. We're going to build an application. First thing you want to do is go to start.spring.io. This is going to allow you to bootstrap your application. And then this is going to be really the kitchen that you use to bake your cake. So what I'll do is I'll go to start.spring.io. So here we have the basic interface for start.spring.io in Spring Initializer. To the left here, we have our project metadata. That's just basically a description of what our artifact's going to be. You can actually add more information, but this is basically going to represent our POM XML. So very simply, you can generate a Maven project or a Gradle project, and you'll choose your Spring Boot version. I'll choose the 1.3.5 release. I'm going to name this the user service. And I'm going to choose some ingredients here. So the first thing I want to do is I want to add web. This is going to embed an Apache Tomcat server in the artifact that I create. So it's going to embed it in the jar, and I can just run that instead of deploying to an Apache Tomcat server. So I'll choose that. Then I'm going to choose Spring Data JPA, because I'm going to have MySQL. Then I'll choose the MySQL driver. I'm also going to choose H2 because I can embed a SQL database in memory in my application for unit testing. I don't have to connect to an external SQL database, so I'll choose H2. And then I'll also choose Redis for caching. And then I'm also going to add in Actuator. So this is going to give me a REST API, which will show me a series of endpoints that I can use to introspect my application running in production. Like I can see the environment variables running live in the environment that I deployed to. I can also see metrics in real time. So I'll go ahead and generate that project. And it's going to allow me to download a compressed file with my project. So this is user service 14, because I do this demo quite a bit. And so what we're going to do is just go to that in the console here. You can see that. OK, so I will go to oops, user service 13. OK, so let's see what's in this directory. I open this up in Atom real quick. Was it 14? Oh. I should really clear these out every time I do this. All right, 14. Thank you. OK, so if I open this up in Atom, we can see the basic project structure here. So we see that we have a Maven wrapper. This means that I'm going to get a wrapped Maven that I can run. I don't have to have Maven installed, but I do have Maven installed, so I'll use that. We can see the POM XML here. Also, if we look in the source, we see a main and test folder. So we have our Java class files generated for each. So we can see a basic Spring Boot application. This is going to be my public static void main with my Spring Boot application annotation on top. We also see that I have my properties file, which is empty. And then if I go into my test directory, I can see just a basic JUnit test that's been set up for this application. And so what I'm going to do is I'm going to open this up. Actually, I'll run it first. Because it's finished and ready for production, I'll go ahead and run the application. And it's going to start up a web server on port 8080. So if we go to localhost 8080, oh, we see that there's an error. It's because I forgot to add REST repositories. But we see that it's running. And if I go to /actuator, should see, or /env, we can see that it's returning back information about the environment. I can also look at the metrics. So one thing that I forgot to add was Spring Data REST repositories, because we wanted to expose a REST API by default. So I'm just going to open this up in IntelliJ, and we're going to build out this user service. OK, so the first thing that I'm going to do is look at the POM XML that was generated for this project. So we can see here some basic information about my artifact. It's a user service. We can see that the packaging is jar. We can see that it's inheriting a parent project, a BOM called Spring Boot Starter Parent. And this is going to bring in a set of transitive dependencies for my project where I can just add in starter projects. So if we look here in the dependencies, we can see those ingredients that create our recipe. So we can see Actuator here. We can see Spring Data JPA. We see Spring Data Redis, as well as web. The thing that I want to add here is the Spring Boot Starter REST repositories. And if I go and restart the application now, we can see that it should return back a response at the root endpoint, which is a hypermedia response. So now we have a response back instead of an error. So this is hypermedia response. This is what we use. It's called HotEOS format. So this is where my repositories are going to be. So I'm going to go ahead and build a user repository now. And that's going to show up here where we can actually go in and look at the users that have been created. So I'll go back to IntelliJ. And I'm going to add a user pojo. So I'll just add a new Java class. And this is going to be a JPA entity, so I will annotate it as entity. And then I will add an ID. And I will go ahead and add a generated value. This is all the live coding I'm going to do, I promise. I'll add a no args constructor because JPA requires that. Then a basic constructor with first name and last name for the new user. And then public getters and setters. And a toString. So now I have my basic pojo for user. Now I need to create a repository to interact and create new users. So I'll go ahead and create a new interface. Call that user repository. And what I'm going to do here is I'm going to extend JPA repository, which requires that I provide that Java class, the user class, and then the type of the primary key. And if we jump into the definition of this JPA repository, we can see this is created as a vendor repository using JPA. And there's a Redis one as well. So we can see that it's inheriting paging and sorting repository. So what's going to happen here is it's going to implement the base abstractions all the way up to the basic repository. So we see paging and sorting repositories extends CRUD repository all the way to the base repository. And so I don't need to add anything or implement anything. I just need this basic user repository to extend JPA repository. And then I can go to my application, and we're just going to test this by adding a few new users. So I will add a new bean called command line runner. Which requires, I'm just going to return a Lambda here. So this is just returning a new instance of command line runner. And what I'll do is I can access this user repository. This has been injected into this method because it is defined as a bean. So I'm going to get an instance of user repository to interact with users. So what I'll do is I'll go ahead and create 2 new users. So I'll use user repository save, and I'll create myself. Oops. And then I'll create one more. Oops. OK. All right, so that looks pretty good. So I've saved 2 users. I've saved myself and then Dame Young. And what I'm going to do now is just restart this application, and we should see some users in that repository. OK, so if I go and refresh the page now, we see that we have a hypermedia link to the users repository, which is a paging and sorting repository. And I can go /users, and we see the response here. This is coming from MySQL. So we see my record and Dame Young. And so that's the basics behind creating a Spring Boot application that uses Spring Data. But now we do need to add in some caching. So let's see how we would do that. So we've done this first part, which is to create the user service and connect it to a MySQL database. So now we want to do the same for Redis, but we're going to use the cache manager. And we're going to use cache annotations on our methods. So we'll have to create a service. So the first thing we're going to do, and I'm actually going to show you the application here. It's very similar to this one we just live coded, but I can't live code all this. It's going to be, you guys would be really bored. So here I have the finished, the thing we're going to do first. I'm going to add in a cache configuration class. I'm going to annotate that as configuration. Now when Spring Boot starts up, it's going to find this configuration class. It also has enable caching, which means that, this configuration class is going to contain information related to configuring the cache manager. So the first thing that I'm going to do, I'm going to have 3 beans here. The first one is going to configure the Redis connection factory. And what we'll do is we'll bind the properties from our application properties file with the Redis port and Redis host. And then we'll return a new instance of Redis connection factory. Now that's going to be passed down to the next bean here. This is the Redis template. So that's going to be our basic Redis client. So we'll pass in this auto-wired bean because it is a bean, and we did define it in the first method. We're going to get an instance of the Redis connection factory, which then we can go ahead and set the connection factory of the Redis template and return it. The final thing here is to then create the cache manager. Very simply, I just create a new instance of Redis cache manager. I've passed in the Redis template that I've defined here in this method, and I've set a default expiration time of 3,000 seconds, which is about 5 minutes, and return the cache manager. And so that's all I have to do to enable caching here. Now what I'll do is I'll create a new REST service for this, create an actual controller. So here we have the contract that I want to create. So instead of just using the basic REST repositories, I'm going to create a version 1 REST API with basic CRUD. And then I'm going to put annotations on a service that's going to allow me to cache records. So the basic description of this contract is that we have a create user, a get user, an update user, and a delete user. Very, very simple. And so the idea here is we're going to put a series of annotations on each one of these contract methods in a service. So the first thing we need to do is to create a new user service. So I will go to the user service class here, and let's just walk through it step by step. So here's the basic CRUD operations. So I have my user repository, which I'm auto-wiring through the constructor here. That gives me access to the user repository to manage user records. And the first one we have here is to create a user. And so what we have is, we'll use first is the cache evict annotation. This means that we're going to invalidate a record in this bucket here, this value user, with the key user.getID. So when I create a new user, I just want to make sure that I'm deleting from the cache any user that might have existed before. In case you deleted a user and you didn't invalidate the cache, I want to make sure that I've deleted that record. And so that's my first method. So if we go and look at the body of that, we see that it calls the user repository. It loads that record using the user repository. Actually, sorry, it saves the record. And then the next one is it uses the cacheable annotation, and that's get user. So what cacheable does is it gets or puts. So it's going to attempt to get the record. If it's not in cache already, it's going to put it in Redis. It's going to put it in Redis with the cache key for the primary key. And so here we see that we're returning back we're using user repository.find1 to get the record with the ID, and then we're going to cache it in Redis. The next one is to update the user, so we'll use the annotation cache put. This is going to put a updated view of the record into Redis, and it'll be returned by the get user method on the next request. And then finally, we have cache evict again, and this is for delete user. So we'll delete the user with the ID that's provided, and then actually delete it from the repository. And so that's basically it. So what I'll do is I'll just run this application. Maybe if we have time, I'll walk through the tests. So if I go back to the console and shut this down, I'm going to go to that new directory here, and I'm going to run this new application. Okay, so if I go to localhost 8080 now, we have a very similar view with our hypermedia for users. And we see that there's no users in here because I didn't initialize it in the command line runner. So what I'm going to do here is use a REST client. And I'm going to call localhost, and then I'm going to call the v1 endpoint for users. So I did create a controller. I don't think I showed it, but I'll just go back to. So here's the controller methods for the create, read, update, and delete. And we're just calling downstream to the user service here. This is a lot of Lambda. It's pretty ugly, but the basics are that it's going to call the user service method, which is actually handling the caching. So if I go back to the REST client, I can go ahead and create a new record here. So I'm going to create myself. So if I zoom in here. OK, so I'll go ahead and post to that endpoint. Oh, what did I do wrong? Oh, of course. The most important thing to do is to make sure Redis is running. So I'll go ahead and start Redis up. And go ahead and restart this app. OK, one more time. So now if I post, we see that the record was created. And now I can actually go to the browser and see that I'm in there, and I can do v1 users and then /1. So you can see that that record's returning back. So that first request that I made to it, that's going to put it in the cache. And now every time I refresh the page, that's going to come from Redis instead of MySQL. All right, so where are we? OK, so now the next step here is, now I built the application. We have our basic user service. Now I want to deploy it to Cloud Foundry. So what is Cloud Foundry? Who's heard of Cloud Foundry or used Cloud Foundry? OK, so Cloud Foundry is just an open source platform as a service, a PaaS. It supports multiple cloud providers. It also supports build packs. So it's kind of like Heroku. So you have like basically an open source Heroku. It supports Linux container deployments using Diego. It also supports Docker container registries. So I'm just going to do a quick overview here of this new model, which is the application server versus the Linux container deployment. So we embedded an application server in the jar earlier, and we ran that. But with Cloud Foundry, we have a deployment model. So we can use application servers, or we can use Linux containers. So I'm just going to go over the difference between how these are operated in production. So the application server, like Apache Tomcat, here's the basic diagram. We're going to have our applications be deployed to one virtual machine. We're going to provision multiple virtual machines and provision this application server and deploy our applications to load balance. So it takes time for operators to spin up new VMs, install the application server. Of course, you can automate this, but it takes a lot of time. Also, there's poor resource isolation typically. So we have our 3 applications here that we've deployed to this virtual machine. They're all sharing the underlying Linux kernel. But if there's a memory leak in one application, it could spill over to another application. And that can cause applications to go offline in that application server. The main thing here is that the runtime environment is typically driven by the operator in an organization. So you'll have gatekeepers who are responsible for maintaining these servers, installing new versions of dependencies, and that can take a lot of time as well. With the Linux container deployment model, we have a very similar diagram. So instead of applications, 3 applications here, we have our containers. And those containers are going to isolate these applications from one another. So these could be microservices all deployed to the same virtual machine. And they're going to have a distribution of Linux that is defined by the developer. And the developer is going to run this runtime environment. So they're going to define what their dependencies are. They can use Java, they can use Python, they can use Ruby. And they can push it to a grid of virtual machines. It doesn't matter if it's one application server, and that's a big benefit. Also, containers take just seconds to start, while VMs can take minutes to provision. And what we get from that is the ability to do auto-scaling. So we can scale up, scale down. And so in this model here, and we're going to do this when we deploy the application, here's just one virtual machine, this one train track, and we have our multiple containers. And this is where we're deploying our applications. So we're going to deploy our user service to a virtual machine where it's going to be scheduled as a container. And the thing with Cloud Foundry that you get is automatic load balancing. So I can have my applications be scaled up and down. I have a grid of these virtual machines, and these containers can be scaled up and down on this grid of virtual machines. OK, so what we're going to do now is we're going to deploy this application and run it. So I'll go to run.pivotal.io, and this is going to be a hosted distribution of Pivotal Cloud Foundry. And I'll just go over the basics here if you're not familiar with Cloud Foundry. As a developer, I have an organization that I belong to. I also have my spaces, and in my spaces, I can deploy my applications. So here in my load balance space, we can see that I have a Redis no caching. I deployed this earlier because I wanted to show the difference between caching and no caching. And we see that's available here. And then below, we have this idea of backing services. So I can go ahead and, as a developer, provision a database. And I'll go ahead and do this now. I'm going to choose Redis. And I'll choose Redis Cloud. And then I get to choose a plan. So we have multiple plans here. I'm going to go ahead and choose the 30 megabyte free plan because I'm broke. And so I'll choose the name Redis. And we'll see that it's added to this load balance space, and I don't want to bind it to any application. So I'll go ahead and add. So we can see now that we have our Redis service, and there's no bound apps. So what we'll do is we'll go ahead and push the user service application. So if we go back to the project and we look at the manifest.yaml, we can see some information related to how this application is going to be deployed into Cloud Foundry. So we see that I've chosen a name here, Redis caching. I've configured the memory. I've chose the number of instances here. I can scale to multiple instances. The host route that's going to be attached to this application. And then the path to the artifact that I'm deploying. Also, I'm specifying that this should be a cloud profile and that it should bind to the MySQL service and Redis. And so what Spring is going to do, by default, I don't need to configure any connection strings. As long as I bind these services to my application, my Spring Boot application, Spring Data is automatically going to configure this to connect to those services by injecting connection strings and overriding them when it's deployed to the environment. So what I'll do here is just use the command line tool here so we can see CF apps. So this is giving me a view of my space. And what I'll do is just CF push. And it's going to push this application into Cloud Foundry. So it's created a route. It's bounded to that route. Now it's uploading the file. Now while this is uploading, I can actually stream. I'll do it from here. So if I refresh the page, and we can see that we now have Redis caching, and it's starting up. I can go ahead and stream the logs from that container. And you can do this on the console as well, but it's just much prettier through the web. So we can see that the upload's complete. And the application's now starting up. All right, that's a lot of log output. So if I go back to the command line here, we should see that it's now healthy. So it's been started. And I can actually go and access this application now. And we can see that it's started up, and here's the hypermedia response with /users. So we see that there's no users in here, so I'm going to go ahead and create one. And at this point, what I'm going to do is I'm just going to compare the no caching example to the caching example. And so before I do that, I do want to show you the environment variables of one of these. Oh, I don't have actuator here. But I can go to the command line, do cfenv Redis caching. And we can see that the environment variables that have been injected into that container. So we can see that for the Redis caching example, we have these environment variables that have been injected into that container running in that environment. And this is how I don't need to specify any configuration with my Spring Boot application. It's just going to find the MySQL connection and connect to it. Likewise, it's going to find the Redis connection and connect to it. So if I load my metrics here, oops. Let's do that again. OK. So there's an option to view metrics coming from that container, so I can look at the network metrics. We can see that there's a spike here. If I go back to my space, I can pull up the other one. So this is the Redis no caching example. OK, so what I'll do first is I'm going to run Apache bench, and we're going to see the difference between the response time, the latency, with Redis and no Redis. So I'll go to, I have a script here that I created. I just have to swap out the URL real quick. OK, so what I'm going to do is I'm just going to create a new record. This is going to be my user with ID 6. And then I'm going to send 250 requests over time using Apache bench on one thread. And this is for the Redis caching example. So I'll go ahead and run that. So we can see that that is now benchmarking. And if I go to the metrics, we should be able to see, cross your fingers. Any second now. I've done something wrong. Something has gone wrong. OK, let's try that again. So Redis caching. I'm probably looking at the same Redis caching, and then no. OK, so what I'll also do is run this against the no caching one. I probably chose the wrong URL. We'll get there. There's the no caching. So here we're seeing the request volume here at the top in blue, and at the bottom we have the response time. So we can see with no caching that on average it's about 50 milliseconds per request, and it's leveling out. This is not using any caching. So now if I can get it to work with Redis added, we can see a tremendous difference between the response times here and the response times when you're going to Redis. All right, so here's the Redis caching container, and just make sure that OK, so my script was just messed up. Of course. That should do it. OK, so now let's do that. sh test sh. OK, so now we're seeing the request hitting the service with caching enabled. And we can see the latency here. It's much less. So on average, it's about 7.5 milliseconds per request. And so that's a lot better. And so that's kind of the idea of using Cloud Foundry. I mean, this isn't the best way to benchmark your application. I'd use something else, a real profiling tool. But for demo purposes, I think it works. And that is about it. So I have, oh, I see someone taking a picture. Go ahead. Thank you. OK, so this is what we've built. We've built a basic user service. We've connected it to MySQL, and we've backed it with Redis. I'm going to go ahead and open it for questions. And while you ask questions, I'll have my contact up here. Follow me on Twitter, of course, and then connect with me if you have any questions. So thank you, guys. I really appreciate your time. Any questions? I see you guys thinking really hard. There's got to be one question. We have 10 minutes, 7 minutes. Yes?
So you were using Redis, hang on, let me get the right distance. So you're using Redis to handle kind of distributed transactions. So I was interested in, I'm doing a similar thing myself, so I'm curious how you guys might approach that. So you're talking, like a distributed transaction state across multiple microservices.
Yeah, so there's a couple ideas there. Now, you can certainly use Redis as a list, and you can store events, and you can cache these events, and then you can create aggregate objects. With a distributed transaction, that's not really, do you have a microservice architecture or just, yeah? Right, so distributed transactions are kind of an anti-pattern. In this case, like two-phase commit. What you would probably want to do is to have a central store where you're adding events. So you have users who are, for instance, if it's a shopping cart, they're adding new items. And what you're going to do is you're going to store these as a ordered set of events. Now, you can use Redis to do this. It's a very efficient way to do it. And then you can create an aggregate object, which is a view of the current state of that object, rather than doing distributed transactions. Now, there might be a different approach here where you put a queue behind each one of your services. And then if you have something that resembles a distributed transaction, at least you can submit a message to one of the other services that will create a message for another service. And then if something happens, there's an error, it can roll back by looking at the event log and just reversing the messages and preserving state. But you can't get around the eventual consistency problem. That is the trade-off of microservice architecture. Good question. Any other questions? OK, well, thank you, guys. I will be around over here if you do have any offline questions. And again, thank you very much.